So in this video, we are going to talk about references and borrowing. In the previous video, we talked about ownership, how that works in Rust and how it is managed with the changing scope, how the ownership of a value is passed from one scope to another or inside a function, and after moving a value, how we can no longer access it through the previous reference. Now, I hope you know all that. If you haven't watched the previous video, I highly recommend watching it because without understanding what is ownership, you won't be able to understand what is references and borrowing. Now, assuming that you have watched the previous video, let's continue with today's concept. So, today we are going to look at what are references and borrowing. Now, if you are from a language like C, then you must be having some idea about what pointers are and how they work in a language like C. References are pretty much similar to that, but have some differences. We'll look at those today. And yeah, like if you have a background in a language like C, then this is pretty much going to be easy for you. If not, then this can be pretty much challenging. But yeah, I'll make sure that by the end of this video, you at least have a basic understanding about how references and borrowing work in Rust. So let's read through the definition. A reference is like a pointer, in that it's an address we can follow to access the data stored at that address. That data is owned by some other variable. And unlike a pointer, a reference is guaranteed to point to a valid value of a particular type for the life of that reference. Now we'll talk about lifetimes later, but what references are, it basically is a value which points to a pointer to some another value on heap. So basically it points to a value which is an address of some other value on the heap. So let us understand that through a code snippet. So let us see this code snippet. Inside the main function, we are declaring a variable s with the let keyword. Let s1 equals to string from the literal hello. So yeah, we are declaring a string with a string s1 containing the literal hello. Then we are declaring a tuple s2 comma len, which is equal to the return of the calculate length function. And inside the calculate length function, we are passing s1 as a parameter. So after this second line of code, which is the call to the calculate length function, we won't be able to access s1 anymore because, as you know, by the rules of ownership, s1 is no longer valid in the scope after we have moved its ownership into the calculate length function. So we are passing s1 into the calculate length function, meaning we are moving the ownership from here inside the calculate length function. Yeah, and in the third line, we are just printing what we have returned through the call to the calculate length function, which is nothing but s2 and the length. Now, what happens inside the calculate length function is that we accept a parameter s, which is nothing but of string type, and then we return a tuple, which is a string, and a usize, which is nothing but a type for number. And inside this function, we are just declaring the length and calculating it in the s dot length fashion, which and the dot length function just returns the length of the string on which it is called, and then we are just returning the tuple s comma length. So we had a variable s1 containing the string hello. Then we moved its ownership into the calculate length function. The calculate length function took a string and then it returned the same string as well as its length. So now whatever we had inside s1, that same thing will be accessible through s2 because we destructured the return of length calculate length function in s2 and length. So yeah, whatever we had inside s2 was moved inside the calculate length function. Then calculate length function returned the same string via the s2 variable and then its length also. And in the third line, we are just accessing the returns which are the s2 and length. And yeah, that is pretty much it. But as you can see, this is a bit complex. Now we knew that we won't be able to access s1 after this calculate length function call, so we returned the string again, and then we are accessing the same value which was in s1 through the s2 variable. So in order to avoid this, we can do it in pretty much a simpler way, which is somewhat like this. We declare a string s1 which is equal to the string from the literal hello. Then we call the calculate length function, and inside the calculate length function, instead of passing this the variable s1, instead of moving the variable s1 from here to inside the calculate length function, we pass a reference to the s1 variable over here. Now what do we mean by passing a reference? Now there is one basic difference, is that we don't pass the ownership of the variable s1 inside the calculate length function. So what does that mean? It basically means that even after this call to the calculate length function, we'll still be able to access the s1 variable, which was not the case over here. After the call to this calculate length function, we were not able to access s1 anymore inside the main function. But over here, we can do that. As you can see in the third line, we are accessing s1 and then printing whatever was returned through the call to the calculate length function. So that is pretty much it. So over here, as you can see, we did not have to use tuples, and we did not have to, return that same string again from the calculate length function and then use it via some other variable. We just passed a reference so that we could continue using the same reference inside the main function. And what we are doing inside the calculate length function over here is that we're accepting a reference to a string, at string. Now at is the symbol used for references, so we are accepting a reference to a string and then just returning a usize, which is nothing but a number type. And yeah, we are just calculating the length using the dot length function, which just returns the length of the string on which it is being called. And we are returning that through the calculate length function and storing it in the binding it to the variable length that we have declared over here. So that is how this is working. So instead of passing the value inside the calculate length function, we are just giving a reference to it and retaining its ownership in the s1 variable. So now let's try to code this example in VS Code. So I hope you are able to see the VS Code screen. Now let's declare the main function, and inside it let's just declare the s1, which is nothing but string from the literal hello. And then in the next line, we are doing is declaring the len, which is nothing but equal to the return of the calculate length function. And inside the calculate length function, we are passing a reference to s1, not s1. So that will be at s1. And then in the third line, we are just printing what was returned through the function and the value of s1. So the length of s1 is len. Then we also have to declare the calculate length function. We do it outside the main function using the fn keyword, which we use for functions. So fn calculate length, which accepts an s parameter, which is nothing but of the type reference of a string. And then we just return a usize, which is nothing but a number type. So return types are mentioned with this arrow keyword. And inside the function body, we just return s dot len, which just returns the length of the string. Now notice we aren't using a semicolon inside the function body, because the last line in a function is generally the return of the function, and we either can specify it with the return keyword or just write the value and not put a semicolon at the end. So Rust will know that it is a return and it will return it. So yeah, this is basically what the code snippet was saying us. And now let's try to check this code for any potential errors before running it using the cargo check command. As you can see, there were no errors or warnings encountered. Now let's try to run this using the cargo run command. As you can see, we got an output that the length of hello, which was our string, is 5. So you can see we were able to access the string s1, which was hello, in the third line even after call to the calculate length function, because we weren't moving its ownership inside the calculate length function. We were just passing a reference to it. So this is how references work. I hope you understood this. Now let's look at how actually this is done in memory. So as I said that the reference is just nothing but a pointer variable which stores the pointer, which in turn points to that memory location on heap, which is actually storing our value, which was a string hello in this example. So yeah, so s1 is on stack, and the pointer in the pointer field inside s1 is pointing to the first location on the heap, the index 0, which is nothing but h of the string hello. So a string are internally stored as vectors, we'll see that later. But yeah, this is how it is done. And then our pointer, our reference, is pointing to this PTR field of S1. So that is how it is being done. And let's see some other examples. As you can see, we are declaring a string S1 over here using the let keyword and binding it to the string from the literal hello. So the type of this will be string and not a string slice. Then in the second line, we are declaring len with the let keyword and then binding it to the return of the calculate len function, and inside it passing a reference to S1. So yeah, I hope you understand this. So that is what is explained in the next snippet as well. That how the scope is working. So S is a reference to a string, and then we return s dot len, and then here s goes out of scope, but nothing is dropped. In the last video, as we saw that while the scope ends, all the values will be dropped. All the values which were declared inside the scope, which were present inside the scope, will be dropped, and we'll no longer be able to use them. But over here, we didn't have ownership to s. We just had a reference to it. So S goes out of scope, but it is not dropped because we didn't have ownership in its of it in the first place to actually drop it. So yeah, that is what is happening over here. So that is why it is pretty efficient, and we can continue using the same reference in the main function. So that is what is mentioned over here. We call the action of creating a reference borrowing. As in real life, if a person owes someone something, you can borrow it from them. When you are done, you just have to give it back. Like, you don't actually own it. You have to return it to the person from whom you borrowed something. So yeah, that was all about what are references and what is meant by borrowing. Now, references under the hood are of two types. One is a mutable reference and another is an immutable reference. Now, this is very important, and yeah, we'll understand the two different types of references now. So what we were doing till now was an immutable reference, because what we passed inside the calculate length function over here was just a reference to the S1. Now, we didn't, actually manipulate the value of S1, change the value of S1 through the reference. To do that, we need actually a mutable reference, which is a reference, not the ownership of the value, but it also let us change the value itself. So yeah, that is what is a mutable reference. So a simple and S1 is just an immutable reference. You can access the value which it is referring to, but not modify it or change it. A mutable reference also refers to some value, but it also gives us the power to change it and mutate it. So that is what is happening in this code snippet. So inside the main function, we have declared a variable s, which is nothing but a string from the literal hello. Then we are giving it, then we are calling a change function in which we are passing a reference to s. Now, as you can see over here, it is just a simple at s. So this is an immutable reference. So inside the change function, we'll be able to access s, the value of s, but we won't be able to modify it. But what we are actually doing inside the change function is taking the reference and then pushing some string to it, appending some string to the end of it. So we are actually trying to mutate it. So this code won't run. So let us still try to code this and let us see what error we get. So let me quickly comment the previous code and again declare the main function. Inside it, let's declare the variable s, which is nothing but string from the literal hello. And then we are calling the change function in which we are passing a reference to s. And then outside the main function, we need to declare the change function with the fn keyword, fn change, which takes some string which is of the type a reference to a string, because we are not passing the actual value, we are just giving a reference inside the change function. So it will receive some string as parameter, which will be a reference to a string, and then it doesn't return anything. And inside the function body, we are trying to append something to the string via the dot push str function. So let us call that function some string dot push str, yeah. And then we are trying to append the string world to it. Now let's try to save this code and let us see what error this code gives us. As you can see, we get a red squiggly line under the sum string. Now let us still try to check this code using the cargo check command, and let us see what the compiler is telling us, that what is wrong with this operation. Let us use the cargo check command. As you can see, we are getting the error. Some string is a reference, so the data it refers to cannot be borrowed as mutable. So what it is basically telling us that the reference that you have passed inside the call to the function is not a mutable reference. So you can just access the value through it, but not change it. So how do we fix this? How do we actually, uh, take a reference with the help of which we can also, mutate the value which it was referring to? So to fix this, let us see this code snippet. Now, if you watched the first lecture, you must be knowing that if you want to, change a variable in the future, we need to declare it as a mutable variable using the mute keyword. So that is what we are doing over here. Now let's try. Let's just comment this code so we can, try this next code snippet. First, let's understand this. So inside the main function, we are declaring a let mutable s, which is a mutable variable, equal to the string from the literal hello. And then inside the change function, as you can see, we are not just writing and s, which is a immutable reference. We are actually giving it a mutable reference with the and mute s word. So yeah, so the change function now is not taking a immutable reference, it is taking a mutable reference. And now you can actually, mutate the value that this reference was pointing to, that this reference was referring to. So yeah, but one important point to note in this example is that still the ownership of s lies in the main function. It is not being passed to the change function. So we'll be still able to use the s inside the main function after the call to this change function. So this is what a mutable reference is. Let's try to code this. In the VS Code, I'll again declare the main function. Inside it, we are declaring a mutable variable s, which is nothing but the string from the literal hello. And then in the next line, we are calling the change function. And inside it, we are passing a mutable reference with and mute s. And then outside the main function, we are declaring the change function, which is taking some string, which is of the type and mute string, which is a mutable reference to a type string, not just a simple reference, which is immutable reference. References are also immutable by default. If we want a reference to be mutable, we have to explicitly mention it using the mute keyword. So we'll just do that, and mute string, which is a mutable reference to a type string. And then there is no return type. And inside the function body, we are just using some string and then the push str function to actually append something to the end of the string. And what we are appending is nothing but a simple world literal to make this string hello world entirely. So yeah, this is what the code is saying. Let me just save it. As you can see, we get no red squiggly lines anywhere when we save this code. Now let's try to check it and run it. Let me just clear the terminal. Now I'll just run the cargo check command. As you can see, we get no errors or warnings at whatsoever. Now let us try to run this code. As you can see, it ran perfectly fine, but we didn't get any output because yeah, we were not printing anything. If we try to print the value of s after this, we can do that using the println macro. Yeah. And then we can just, do something like this. Then s, yeah. Now, as you can see, we are still able to access the value of s after the call to this change function because we were never passing the ownership of s inside the change function call. We were just passing a mutable reference to it. So that is why in the third line, we are again able to access the value of s. And let us try to run the code now. Let us first clear the terminal and cargo run. Now, as you can see, we get an output. The value of s is hello world, which was the expected output because inside the change function, we were pushing the string world at the end of the literal hello that we had. So yeah, that is all about what was there in this example. Now let us see, different rules relating to mutable and immutable references. So I know this video is getting a bit long, but yeah, these are very important concepts. And if you understand them once, then, all rest concepts in Rust will be pretty much easy for you to understand because they build up upon these basic concepts. So yeah. So let us first understand these three rules. So what the first rule says is can have multiple immutable borrows. So we can, um, reference a value immutably multiple times. Then the second rule says that can have only one mutable borrow at a time. So if you are, passing or having a reference to a value mutably, then you can have only one at a time. Means we can mutably borrow only once. And what the third rule is saying that cannot have a mutable and immutable borrow at the same time. So if you are borrowing a value mutably, you cannot borrow it immutably, and if you are doing immutably, you cannot borrow it mutably. So why is this so? So let's think of it from a logical point of view. If we have a immutable borrow to a value, then we are not going to change the value, we are just going to access it through that reference. So this is okay. But once we have a mutable borrow, then we are actually changing that value which we are referring. So if we have two mutable borrows, then there will be two references trying to change that value at the same time. So which one will change it first? The first reference or the second reference? So there will be a race condition over here. So that is why Rust doesn't allow this. Same thing is happening over here. We cannot have a mutable and immutable borrow at the same time. So let us say you have a reference 1 which is trying to, actually change the value, mutate it, and reference 2 which is an immutable reference which is just trying to read the value. Now which one will happen first, whether the reference which is trying to read it will read it, or the reference which is trying to change it will change it? So again we have a race condition over here. So yeah, Rust says ki no bro, you cannot do this, you cannot have a mutable and immutable borrow at the same time to avoid this race condition. So pretty much logical, these rules make a lot of sense. This is why Rust is memory safe. So that is what is explained in this code snippet above. I hope you are able to see it. Yeah, so we have we have declared a mutable variable s, which is nothing but a string from the literal hello. Then we are declaring r1, which is nothing but a mutable reference to s. And then we are again declaring r2, which is also mutable reference to s. Now if you try to change the value of s through both these r1 and r2, so which will happen first? Whether r1 will change it first or whether r2 will change it first? Because in both the conditions, your output will be different. So this is again a race condition, and Rust won't allow you to do this. That is why there is a symbol with a question mark over it. This is the Rust symbol for the code won't compile. So yeah, and then again in the third line we're trying to print both the references. So this won't happen. Rust won't allow you to do this. So this is one solution to it, in wherein we are again declaring a mutable variable s which contains the string from the literal hello, and then we are declaring a code block with the curly braces. Now this is a scope. Inside the scope, specifically inside the scope, we are declaring a variable r1 with the let keyword, and which is nothing but a mutable reference to s, which was declared in the first line. And as the scope ends, as we encounter the closing curly brace, r1 goes out of scope. So here we can make a new reference with no problem, because after the end of this curly brace, r1 is no longer valid. So now we can have a different mutable reference. So I hope you understand the difference between having two mutable references at the same time and having them in different scope, because we know for sure that when the scope ends, the first mutable reference will be dropped, and so r2 can exist after that with no problems. So I hope you understand that. This is a very important point. Now let's try to understand this problem in which we have immutable and mutable references at the same time. So what we have done here is declared a mutable variable s, and we have bind it to the value to the value of type string, which is nothing but the string from the literal hello. And then over here we are declaring r1, which is nothing but a immutable reference, because we haven't used the keyword mute over here. So we can just access the value of s through r1 but not actually change it. So yeah, no problem in this. Again in the third line we are declaring r2, which is also an immutable reference to the string s. So no problem, because we know that we can have multiple immutable references to the same value, because they are not going to change it, they are just going to read it. So yeah, multiple things can read a single value at the same time, no problem in it. But in the third line, we are having R3, we are declaring R3, which is nothing but a mutable reference to S. Now with R3, we can actually change the value of S. So now there will be again a race condition. What if R1 and R2 are trying to read the value of S, and at the same time R3 is trying to change it? So which will happen first? Whether R3 will change it first or R1 and R2 are going to read it first? So again we have a race condition. So Rust won't let you do this. again the question mark symbol that the code won't compile. And in the third line we are trying to print all the three references. So yeah, this won't work. Now in the next example, what we are trying to do what we are trying to do is explain a pretty important point. As you saw in the previous code snippet, that we cannot have we can have multiple immutable references but not mutable and immutable at the same time. But then in the next code snippet, we are actually doing what we said just now is not possible. We are also having immutable references R1 and R2, and then we are having a mutable reference R3. Now, as you can see, this code will compile. We'll also try to check it in VS Code, but this code will compile. But how so? Like, there are two immutable references and there is also one immutable references. We just said that this is not possible. So the reason this is happening because Rust is a statically typed language. Now, while you're compiling the code, the compiler already knows what all lines of code you have written. It is checking it one by one, and that is what is meant by statically typed. The compiler already knows all the lines of code that you have written at compile time, and what is happening over here is we have declared a mutable variable s, which is of the type string from the literal hello, and it is mutable, so we can change it. And then in the second and third line we have declared two references R1 and R2. Both are immutable, meaning we can access the value of s through it but cannot change it. So yeah, no problem in this because we can have multiple immutable references which are just going to read the value, not change it, so that is fine. Then in the next line we are printing R1 and R2, no problem. But then after that we are trying to define R3, which is a mutable reference to s. Now why this is allowing it, why this is not giving an error? Because the the compiler already knows that after this println statement we are not actually using R1 and R2 anymore in our code. So what it will do is it will drop on R1 and R2 after their last usage. So their last usage in this code snippet was this println statement. After R1 and R2 are used over here, they will be dropped. So after this println statement, the compiler will think that there are no immutable references or there are no previous references to s, and then it will go ahead and declare this mutable reference s, which is R3, with no issues. So let's actually try to code this in VS Code. Let us clear the terminal. And let me just comment out the previous code. And again declare the main function. Inside it we have a mutable variable s, which is nothing but string from the literal hello. Then next two lines we are declaring the two immutable references. Let us quickly do that. Let R1 equal and s, which is the first immutable reference. Then let R2 equal again and s, which is the second immutable reference. Then let's just print it using the println macro. Now we are printing the value of R1 first and then R2 finally. Now inside the main function, this is our last usage of R1 and R2. So after this, the compiler will think that R1 and R2 no longer exist. So we can go ahead and declare R3, which is a mutable reference, without any problem. Let R3 equals to and mute s. Remember, we have to add the mute keyword in order to declare a mutable reference. And then let's print R3. Like this, yeah. So let's try to save this code. As you can see, we get no red squiggly lines, which means that this code compiles perfectly fine. And let's try to actually check this code using the cargo check command and then run it. So cargo check. As you can see, we get no errors or warning whatsoever. Now let's try to run it using the cargo run command. As you can see, it printed hello and hello first, which is exactly what we are doing in this println statement, printing it via the immutable references R1 and R2. And then it is printing just a single hello, which is what we are doing in this line, printing it via the mutable reference R3. So I hope this is fine to you, how the immutable references are dropped after their last usage. And then after that, we can go ahead and freely declare any more immutable or mutable references. So I hope this is clear. Now let us see one last important point known as dangling references. Now what do we mean by dangling references? Dangling references means basically a reference to nothing. Now let us understand this, why the code snippet mentioned over here. In the main function, we are declaring a variable reference to nothing and making it equal or binding it to the return of the dangle function. Now what we are doing in the dangle function is just returning a reference to a string. And inside the dangle function body, we are declaring a variable s, which is nothing but string from the literal hello. This is of type string. And then in the last line with no semicolon, do you remember that the return of a function is mentioned in the last line with no semicolon? So that value will be by default returned by the function body. So yeah, we are returning a reference to this s. But wait a minute. S was declared inside this dangle function body. And as we encounter the closing curly brace of the dangle function body, the value of s will be dropped. So how are we returning the reference to s? So this is a problem, and this leads to a dangling reference. Now there is a solution to it, which is just return the string instead of returning a reference to it. So this code over here won't work. And the solution it is, instead of returning a reference, we actually return the entire string, so that the variable that we have made equal to the return of the dangle function will contain the string which was declared inside the dangle function. So the ownership of string will be moved from the dangle function to the main function, which we are actually doing in the next code snippet in the solution. But that is not what is happening over here. We are trying to move the reference. So let us actually try to code this in VS Code, and let us see what the compiler is telling us. Let us clear the terminal, and let me just comment out the main function, the previous code, and let us declare the main function again. Inside it, we are declaring a variable which is reference to nothing, which is equal to the return of the dangle function. And then outside the main function body, let us declare the dangle function using the fn keyword, which is returning a type. The return type is mentioned with an arrow symbol, returning a type of reference to a string, not a string but reference to a string. And inside the function body, we are declaring a string let s equals to string from the literal hello. And then in the last line of the function body, we are just returning the reference to this string that we just declared, which was s. Let's try to save this. As you can see, we get an error. Now we get a red squiggly line under the return of the function. Now let us actually check this code with cargo check command and see what the compiler is telling us. So let us do that. Cargo check. As you can see, we get an error, cannot return reference to local variables. What it is saying that the variables which were declared inside the function body, you cannot return a reference to those variables, because as soon as the function body ends, as soon as the scope of the function body ends, all those variables which were declared inside the function body will be eventually dropped. So how can we return a reference to those? That will be just pointing to nothing inside the memory. So yeah, we cannot do this. A simple solution to this is changing the return type of the dangle function from and string, which is a reference to a string, to an actual string, and then returning the actual string instead of the reference to a string. So this will work pretty much fine. As you can see, when I saved the code, I get a warning, not an error. Now what this warning is, we'll check it out later, but we don't get any error. Now let me again try to run this code, and let's first clear the terminal and do cargo check. As you can see, I get a warning but no error. And even if we run the code, it will run, we will get a warning but no error. Now we'll see later what this warning is, but that was all about dangling references. So yeah, when the function body ends, all the locally declared variables will go out of scope. So you cannot return a reference to those, because that reference will be simply pointing to nothing inside the memory, and Rust won't allow us to do that. So that was all about this video. Let us just quickly recap what we discussed about the rules of references. At any given time, you can have either one mutable reference or any number of immutable references. But you cannot have both mutable and immutable. You can have either n immutable references as much as you want. But even if you have one mutable reference, then that is it. You can no longer have any more mutable references or immutable references. And then references must always be valid. As you can see that we cannot make an invalid reference, as you saw in the dangling reference example. So that was all about this video. Stay tuned for the next videos, because we are going to discuss some pretty sick and advanced concepts in Rust. And by the end of this playlist, you will be expert in Rust, and you'll be able to explore more beautiful things which come in Rust, with every update, and play with it as you wish. But yeah, this is all about this video, and I hope you enjoyed it. Like the video, subscribe it, share with your friends if you like the video. Yeah, and I'll see you in the next one. Thank you.